Hello students, how are you? I wish all of you will be healthy and safe. Okay, students, in the last video I told you about the various Python operators. Okay, so in this video I will tell you about the Bitwise operators. Okay, so Bitwise operators are useful in digital electronics. Okay, in Bitwise operators, the bit, what do you mean by bit? Bit means binary digits. Okay, so how many types of binary digits are? Only there are two types of binary digits, 0 and 1. We can call them binary numbers also. Okay, so what are binary numbers? Binary numbers are in the form of 0 and 1 and have base 2 because it has only 2 digits. That's why these are called binary numbers. Okay, so next one is decimal numbers. Numbers you used. Okay, usually you use the number are known as decimal numbers. Okay, so they have the digits 0 to 9 and have base 10 because 0 to 10 if you count, so then it will become 10. Okay, so that's why we call them decimal numbers. They have base 10. So next question is, to understand Bitwise operator you should know how to convert decimal to binary and binary to decimal. Okay, so let's take an example. How to convert 25 as a decimal number? Here we have the base 10, so it means it's a decimal number. Okay, here we have the base 2, it means it's a binary number. So the question is how to change this decimal number to binary number. Okay, it's so simple. So if you are converting 25 to binary number, so write down 25 here and divide the number by 2 by base. Okay, now 2, if we divide 25 by 2, then it will gives 12 and remainder will be 1. Okay, it's the divisor, it is the quotient, and it is going to the remainder. Okay, now again divide by 2, 2 6 are 12 and remainder will be 0, and 2 divided by 2, 3 just 6 and remainder will be 0, and the 2 ones are 2 and remainder will be 1. Okay, now we are getting some numbers in the form of 1 and 0, that is 1 1 0 0 1. So this is the binary number. So count from this side, count from bottom to up side, 1 1 0 0 1. So this is the number 1 1 0 0 1. So this is your binary number. So this is the method to convert a decimal number to binary number. Okay, so there is a shortcut method also to convert decimal number into binary number. So what you have to do, first of all write down the number starting from 1 like this, 1 and double of 1 will be 2 and the double it 4 8 16 32 like this. Okay, now for 25 up to 16 is enough. Okay, so what you have to do, find out the number from these number whose sum is equals to 25. Okay, now 16 plus 8 24 and 1 25. So what you have to do, write down 1 in front of those number. Okay, now 16 8 24 and the remaining number is 0. Okay, write down 0 in the remaining number which are not included. Okay, 0 and 1. Okay, now 16 plus 8 24 plus 1 25. Okay, for these numbers you have to write down 1 1 and for remaining number you have to write down 0 0. So this is the binary number of 25. You can check it, 11001 11001. Okay, so next you have to learn how to change binary number to decimal. Okay, let's take an example. Suppose we have a number 10110. This is your binary number and you have to change it into decimal number. What you have to do, first of all you have to put the power. Okay, starting from 0 0 1 2 3 and 4 like this. Now what you have to do, write down 0 multiplied 2 to the power 0. This is the power. Okay, 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3 plus 1 into 2 to the power 4 like this. Okay, Now cut down all the zeros from it. So 0 into any number will be 0, or 0 into any number will be 0. So don't write it. Okay. Now 1 into 2 to the power 1 will be 2, and 2 square into 1 will be 4, and 2 to the power 4 will be 16. The sum of all these numbers, 16 plus 4, 20 plus 2, 22. So this binary number is equal to 22 as a decimal. Okay. So there is a shortcut method also. So what you have to do, write down the numbers from 1, 2, 4, 8, 16 as we have written down in the previous method. Okay. What you have to do, write down all your what you have to. So now we have the number 10110. So write down, okay, 1 0 1 1 0, and find out the numbers who have 1. Now the 16 has 1, so write down 16 plus 4 20 and 2 22. So 1011 will be equals to 22. Okay, so this is the shortcut method to convert binary number to decimal number. Now you are able to convert decimal to binary and binary to decimal. Okay. Next you have to learn how to add two binary numbers. Okay. To understand the addition of binary numbers, first of all you should know 0 plus 0 is equals to 0, and 0 plus 1 equals to 1, but 1 plus 1 equals to 0 and 1 carry. Okay, so you have to remember 1 plus 1 equals to 0 and 1 carry. Okay, now let's take an example. Now 1 1 0 1, that is equals to 13. Okay, now 1 0 1 1, that is equals to 11. Okay, now find out the addition. So 1 plus 1 plus 1 equals to 0, so put down 0, and 1 will be carried here. Okay, now again 1 plus 1 will be 0 and we carried here. So 1 plus 1 equals to 0 and carry here. And now 1 plus 1 0, and 0 plus 1 1, and 1 will be the carry, and this number will be equals to, okay, you know very well how to convert this binary number to decimal. It will become 24. Okay, so this is the way to find out the addition of two binary numbers. Okay, now come to the point, bitwise operators. Okay, so in Python, bitwise operators are used to perform bitwise calculations on integers. Okay, note, Python bitwise operators work only on integers. Okay, so the integers are first converted into binary. You know very well how to convert the decimal number into binary, and then operation are performed on bit by bit. Okay, hence the name bitwise operators. Okay, you know it. First of all, the number is converted into binary number, and that binary number is converted into decimal again. Okay, then the result is written in the decimal format. Okay, now, so how many types of bitwise operators are? There are 6 types of bitwise operators. Now, bitwise AND operator, bitwise OR operator, bitwise Not or Complement operator, that is bitwise XOR, and bitwise left shift operator, and bitwise right shift operator. Okay, so let's explain them one by one. Okay, so now first of all you know bitwise AND operator. Bitwise AND operator. So for AND operator the sign is used, that is single AND sign is used to find out bitwise AND. Okay, so now first type of bitwise operator is bitwise AND. To understand bitwise AND operator, first of all you have to remember this table. Okay, in the previous video I told you about the AND operator. Okay, so if two conditions are true, yeah, all conditions are true, so in this case it returns true. Okay, if either of the one condition is false, it returns false. So here I have 0 is represented as false condition and 1 is represented as true condition. Now you are taking false and false will become false. Okay, now false and true will be false, and true will be true. Okay, so according to it, because bitwise operator works on bit by bit, so bit by bit it will check. Now find out. So 0 and 1, what will you can calculate from this side also. 1 and 1 will be 1, and 1 and 1 will be 1, and 0 and 0 will be 0, and 0 and 1 will be 1. What will be the result? The result will be obviously 1101. 1101 equals to 13. Let's check it. Okay, write down 12 and 13 equals to what? That is 12. Okay, what is the result? The result is 12, and we are saying that the result will be the 13. Okay, I think there is a problem. Okay, so sorry, 0 and 1 will be 0. Okay, then result will be 12. Okay, so this is the bitwise operator. Okay, next you will learn bitwise OR operator. Okay, so next is bitwise OR operator. Okay, bitwise OR. For this use this sign. Okay, so then use this table. The OR operator returns true if either of one condition is true. Here you have the two false condition, false or false will be false. If you use false or true, it will return true, and true or true will return true. Okay, similarly you can check. Okay, write down. So for true or true returns true, true or true returns true, false or false will return, both condition are false, so in this case it will return false, and false and true it will return obviously false, and true it will return true. So what will be the result? What will be the answer? 1101. So 1101 obviously it is 13. Okay, let's check it. Okay, the 12 or 13, the result will be 13. Okay, now this is the function of bitwise OR operator. Okay, so next type of operators are bitwise not operator. Okay, so bitwise not operator is not easy to understand. To understand bitwise not operator, first of all you should know one's complement, and after that two's complement. Okay, so first of all you should know what is one's complement. Okay, to find out the one's complement of the number, what you have to do? Invert all digits. Let's take an example. Suppose I have a number 10010. So you have to find out the one's complement, invert all the digits. So what you have to do? Now 1 will become 0, and 0 0 will become 1 1, and the 1 becomes 0, and 0 will become 1. So this is the one's complement of this number. Okay, so next question is how to find two's complement. Okay, next question is how to find two's complement. To find out two's complement, add 1 to add 1 to one's complement. Okay, add 1 to one's complement. Okay, find out 1 to one's complement. Okay, so what you have to do now? I have this number in the form of one's complement. So what you have to do? You have to add 1. Okay, so 0 1 1 0 1. You have to add 1. Sorry, you have to add 1. Okay, you know how to add numbers, how to add binary numbers. So what will be the result? 1 1 plus 1 will be 0. Sorry. 1 plus 1 will be 0, and 1 will be the carry. Now next number will be 1. After that is 1 1 0, 1 1 and 0. So this is the two's complement of this number. Got it? To find out to understand Bitwise Not Operator, first of all you should know what is 1's complement and 2's complement. How to find out the 1's complement? It's simple, invert all the digits, make 1 to 0 and 0 to 1. Okay, so now this is the 1's complement of the given number. And how to find out the 2's complement? Simple, add 1 to the 1's complement of the number. So this is the 1's complement of the given number. Now add 1. So how to add the binary numbers? You know very well. 1 plus 1 will be 0 and 1 will be the carry. 1 and 1 1 0. So this is the 2's complement of this number. Okay, got it? And the question is, why do we find the 2's complement? Basically, in computer, negative numbers are not stored. Negative numbers are stored in the form of positive numbers. Okay, if you want to store negative numbers, so in this case you have to find out the 2's complement of the given number. Okay, for example, suppose, how can we represent minus 13? Okay, in binary form. In binary form, what you have to do, first of all, convert 13 into binary. So what will be the result? It will be 1 1 0 1 8 4 12 and 1 13, and it is the representation of 4-bit, but I want to represent it in 8 bits. Okay, now it is the 8-bit representation 13. Okay, now I want minus 13. So what you have to do, you have to find out the 1's complement. Okay, so what will be its 1's complement? It's 1's complement will be, so what is the way? Invert all the digits. Okay, it will be 1 1 1 1 and then 0 0 and 1 0. It's the 1's complement, and you have to find out the 2's complement. 2's complement will be, what will the 2's complement? It will be 1 1 1 1 and 0 0 1 0 and plus 1. So what will be the result? Okay, 1 plus 0 and 1 plus 0 1, 1 plus 0 1, and the remaining numbers will be same. What you have to do? Okay, Control C and Control V and 1. Okay, so this number is represented as minus 13. Okay, got it? So this is the function of Bitwise Not Operator. Bitwise Not Operator is used to find out the complement of the given number. So for example, let's take an example. I am finding out that using the tilde of minus 12. I want to find out the complement of 12, so it will return minus 13. Okay, so minus 13 will be represented as this. Okay, this is the representation of minus 13. So this is the function of Bitwise Not Operator. So now question is, how can we say that not 12 is equals to minus 13? Okay, so let's take example. Let the 12 represent 12 as a binary digit. Okay, so it will be 8 1 1 0 0. Now represent it in the 8 digits and find out its 1's complement. Find out its 1's complement. The 1's complement will be 1 1 1 1 1 and 0 0 1 1. Okay, now got it. The 1 1 1 0 0 1 1 1 1 1 0 0 1 1. It means that not 12 is equals to minus 13. Okay, so this is about the Bitwise Not Operator. Okay, it is little bit difficult to understand, but you have to revise, you have to remember these points. Okay, you have to study them again and again, then you can get it. Okay, if you face any problem, you can call me. Okay, or whenever your class will be offline, then I will discuss them again. Okay, so next type of Bitwise operator is XOR. Okay, how to use it? We use XOR operator by using this cap. Okay, in the numeric keypad you can see this symbol on the digit 6, okay, above the 6. Okay, now to understand Bitwise operator, Bitwise XOR operator, you have to learn this table. So if two digits are same, then it returns 0, like this. 0 XOR 0 returns 0. 1 XOR 1 returns 0. If both the operands, if both the digits are different, then it returns 1. Okay, so let's take an example. For example, 10 and 10 XOR, okay, 8. What will be the result? Let's guess it. For example, 10. So what will be the binary representation of 12? 10, sorry. It will be 8, 4, 8 and 2, 10. So it will be 1, 0, 1, 0. And 8, how can we represent 8 as a binary number? It will be 8 meaning 1, 0, 0, 0. Okay, so this is the representation of 8 in binary. Now use XOR operator. Okay, now 0, 0 or 1, 1. Both the digits are same, 1 and 1. It will return 0. So now it will be 0. Now 0 and 0, both digits are same, then it will return 0. Now both the digits are different. Okay, in this case it will return 1, and here it will return 0. So what will be the answer? Now 1, 2, the result will be 2. Let's check it. Now 10 epsilon 8, the result will be 2. Okay, this is the use of XOR operator. Okay, so next type of Bitwise operator is left shift operator. Okay, so first of all you should know how do digits are shifted. Let's take an example. For example, I have 12 equals to 12 equals to 1, 1, 0, 0. It is the binary representation of 12. 8 and 4, 12, 12. And I am using left shift operator like this. 12 left shift by 1. So it means you are shifting one digit left side. Okay, you are shifting one digit left side. So what will be the result? Okay, let's see. So 1, 1, 1, 1, 0, 0. And you have to shift only one digit. Okay, to understand this, first of all convert it into 8-bit representation. And okay, now start from this side. Okay, this one will be shifted to left side this here. Okay, this one will be shifted to this, and this one will be shifted to this, and this 0 will be shifted to this. Yani all the digits will shifted to left side one by one. Okay, now what will be the result? Now what will be the result? Result will be now, and this 0 will shift it to this side. Okay, now shift this 1 this here. Okay, now this 0 will be shifted to last corner. Okay, now here you will have 3 zeros. Okay, now this one will be shifted to this, and this one will be shifted to this, and now this 0 will be shifted to this here, and this 0 will be shifted to this side, and that 0 was shifted to this side. So now it will become this. Now convert it into the decimal number, it will become 24. Okay, now let's check it. Now okay, now tired of 12 left shift by 1, the result will be 24. Okay, now what will be the result if you use 12 left shifted 12 left shifted by 2? So what will be the result? Result will be 48. How? Let's check it. Now it is the shifting by 1. Now shift this to second time. Okay, now what will be the result? Let's check it. Now 1 will be shifted to this side. Okay, now this 0 will be shifted to last one. So here you will get 2 zeros. Okay, now this is the 2 zeros. So no. Here you will get okay, now here you will have 2 zeros. Okay, now because this 0 is shifted to last one, and this one will be shifted to here. Okay, this one will be shifted to here, 1 1, and the last one you will have 4 zeros, 1 2 3 4, because here you have 3 zeros and this 0 will be shifted to this side. So now what will be this number now? 1 2 4 8 16 32. On 32 and 16 we have 1 1, so result will be 48. Okay, so this is the left shifting of binary digits. Okay, so now, so in this way, in the second shifting you will get 48. Okay, so next and last type of bitwise operator is bitwise right shift operator. Okay, bitwise right shift operator, bitwise right shift operator, the symbol will be reversed like this, bitwise right shift operator. Okay, now suppose I have a number like 10. Okay, now you have to shift by 1, right shift by 1. So what will be the result? Now first of all convert 10 into binary form, so it will be 1 0 1 0. Okay, now 1 0 1 0, you have to shift right shift by 1. So what you have to do, you have to shift this one digit to right side. Okay, so what will be the, and it will goes to garbage. Okay, so what will be the result? The result will be 0 1 0 1. Okay, because this 0 is shifted to garbage. Okay, now what we have now? We have only 1 0 1, and the what will the 1 0 1 1 0 1 will be equals to 1 2 4 4, and 1 will be 5. Let's check it. Okay, 10. Okay. Okay. 10 right shifted by 1, so that will be the result. That will be 5. Okay, now this is the single shifting. If you are using the second shifting controls, okay, now you are using the 10 to second shift. Okay, so what will be the result? Now what will be the result? The 1 will be now in the first shifting you are getting 5. 5 will be represented like 1 0 1. Okay, now what you have to do, you have to shift this 1 to right side and it will goes to garbage. So what will be, what you get? You will get only 1 0, and 1 0 is represented by only what is the decimal number representation of 1 0? That will be 1 2, only 2. Okay, let's check it. 10 right shifted to 2, what will be? That will be 2. Okay, so all this about the bitwise operator. Okay, thank you students, have a nice day, be healthy, be safe.